This is example 6 from lesson R.3. And what you see are 6 polynomials that we are going to try and factor. All right. In part A, we're going to factor the polynomial y squared minus 9y plus 14. And we're going to try and factor this into a set of parentheses times another set of parentheses. Okay. Now, in the front, we're going to put the square root of our variable out here at the front. So y times y will actually give me that y squared in the front. All right, in the back, I'm trying to find things that'll multiply and give me 14 that will also add together and give me negative 9. Well, I know that 7 times 2 will give me 14, and that negative 7 plus negative 2 will give me negative 9. And so this is how part A will factor. In part B, the first thing I notice is that all of my numbers end in 0. That means that these terms are all divisible by 10. So the first rule of factoring is to pull out the greatest common factor if there is one. So I'm going to bring a 10, and they don't have anything else in common because I've got m squared here, an m and an n here, and an n squared there. All right, so let's see. 10 goes into 30 3 times, so we got 3m squared. 10 goes into 200, that's 20 times, so we got 20mn. And then 10 goes into 70, 7 times, so we have 7m squared here. All right, now, my trinomial back here will actually factor one more time, okay? So what I'm going to do is I'm going to multiply 3 times the negative 7 here. This is going to give me negative 21. And I'm looking for numbers that will multiply and give me negative 21, but they'll add together and they'll give me negative 20. So I think negative 21 and positive 1 will do that. Negative 21 times 1 is negative 21. Negative 21 plus 1 is negative 20. So this problem will actually turn into 10 times 3m squared minus 21mn plus 1mn minus 7m squared. So notice what I did. I took the 20 out and I put in the negative 21 plus 1 in its place. All right, and then what I'm going to do is I'm going to do the grouping on this polynomial right here. The 10, I'm just going to kind of bring along for the ride because it's going to appear in my final answer here. Okay, so I'm going to group my first two together. So you have 3m squared minus 21mn. And then I'm grouping the 1mn and the negative 7m squared together. And now I'm going to find the greatest common factor. So let's see, 3 can go into 3 and 21. And both of these terms have an m. Okay, so 3 goes into 3 one time. And then m squared divided by m, that's just m. 3 goes into 21 7 times. And m divided by mn is just going to leave me with that n. All right, over here, the numbers only have a 1 in common, and then both of my terms here have an n. All right, so what I'm going to do is they both have an n. We're going to divide now. So 1 goes into 1 one time, n goes into mn. It's going to leave me with an m. 1 goes into 7 times, and n squared divided by n is going to leave me with another n. Okay, now remember, I'm going to factor by grouping one more time. My parentheses actually do match. They are exactly the same. So I'm going to pull out the greatest common factor, and that's going to be m minus 7n, and then when I do my little division trick here, there's going to be a 3m left over here. And when I do my little division trick back here, there's going to be a positive 1n left over. And then this 10 is just going to come down and be part of my answer. So there is B, which is now factored in all its glory. All right, and now we should probably erase some of this to make some room so that we can get to the other 4 problems. Okay, part C, we're supposed to factor 64y squared plus 16y. And again, I'm going to take the 64 and I'm going to multiply it by 1 right here. So 64 times 1, that's 64. So I'm looking for things that will multiply and give me 64, that will add together and give me positive 16. And it looks like that's going to be 8 plus 8. All right, so this problem is 64y squared plus 8y plus 8y plus 1. Okay, all right, so let's group the first 2 together and the last 2 together. All right, 8 can go into both 64 and 8y. Both of them have a y. 8 goes into 64 8 times. Y goes into y squared y times. 8 goes into 8 1 time, and then these y's will cancel each other out. Back here, the greatest common factor is 1, and we actually do need that placeholder there. Because when we go to do the next step, which is factoring out the greatest common factor again, the parentheses, we have an 8y plus 1. And then when I do my little division trick and get rid of that, there's just an 8y left here. And then when I do my division trick and get rid of that, there's just a plus 1 left here. So it looks like C factors into 8y plus 1 times 8y plus 1. And if you want to be fancy, you can write this as 8y plus 1 squared. Okay. Now, for D, we have 9m to the 4th minus 30m squared n plus 25n squared. We're going to do the same thing. I'm going to multiply 9 times times 25, and that is going to give me 225. Now, a quick way to multiply by 25s is to think about money. How much money is there with 9 quarters? There's $2.25. So 9 times 25 is going to give us 225. All right. So now I need to multiply to 225 and add together and get negative 30. I believe this is going to be negative 15 and negative 15. So our problem is going to become 9m to the 4th minus 15m squared n minus 15m squared n plus 25 n squared. Okay, and let's group the first 2 together and the last 2 together. So it looks like 3 can go into both 9 and 15, and both of them have an m squared. So 3 into 9 goes 3 times. M to the 4th divided by m to the 2nd is m to the 2nd. 3 goes into 15 5 times, and m to the 2nd times n divided by m to the 2nd is just going to give me n. Okay. All right, that negative, remember we're going to factor that out. And it looks like 5 can go into both 15 and 25, and both of these terms have an n. So negative 5 into negative 15 is going to be a positive 3. And then we're going to have an m squared because these n's will cancel. And -5 into +25 is going to give me -5. And then n into n squared is going to leave me with an n right here. And so we're going to do the greatest common factor one more time. My parentheses match. We've got 3m squared minus 5n. And then my second parentheses, once this is gone, it's going to leave me with 3m squared. And then once this parentheses is gone, it's going to leave me with a -5n. So it looks like D is going to factor like this. Or you can write this as 3m squared minus 5n, and then close your parentheses and square it. All right, E, this is a difference of squares because p squared is a perfect square, 100 is a perfect square. These factor pretty quickly. You just go ahead and you draw your two parentheses in there, and we know that p times p will give me p squared, and 10 times 10 will give me 100. And since there's no middle term in here, I know that one of these is going to be positive and the other one's going to be negative. And there's our answer for E. Then when we go to DF, it looks like it's going to be a difference of squares, but 32 is not a perfect square. But remember, the first rule for factoring is to pull out the greatest common factor. So if we can find something that would go into 32 and also into 162, we should probably pull that out in front. And it looks like 2 can go into both of those. So we're going to have 2 times 16 y to the 4th minus 81. Okay, and now we actually do have a difference of squares because 16 is a perfect square and so is 81. So we know this is going to factor into 2 parentheses, right? And 16 is actually 4 times 4. And y to the 4th is actually y to the 2nd times y to the 2nd. And 81 is actually 9 times 9. And remember, because there's no middle term, one of these is going to be positive and one of these is going to be negative. But wait, there's more. This second parentheses right here will actually factor again because it's another difference of squares. 4 is actually a perfect square and so is 9. So we have to factor one more time. Now, I'm going to leave the 2 and the 4y squared plus 9 alone. But I know that the 4y squared minus 9 will actually become 2 more parentheses. So 4 is actually 2 times 2. And y squared is actually y times y. And then 9 is actually 3 times 3. And again, because there's no middle term, I know one's going to be positive and one's going to be negative. So F, which factored several times, its final form is going to look like this right here.